Thank you for joining. And today our topic is how does technical debt affect security? So we're here as always with our founder and CEO, Ken Fee. Ken has been on different technology teams for the past 30-ish years. And, he's kind of seen it all at this point. So, Ken, why don't you tell us what the definition of technical debt is, just to get it started?
30-ish years. We shouldn't mention that anymore. You're starting to date me. But seriously, Jen, thanks for pulling this together, and hello everyone. Like Jen said, I've worked on teams over a bunch of years and been in a lot of different situations where it's to throw something together quickly or haphazardly, and something that's a band-aid, but you have to hit a launch time goal, or it's critical to fix this application, or to bring connectivity up, and these are the things that create technical debt. An example, I was a Marine in the late 90s, and I was in data communications, and we all had a similar set of technologies, but we weren't all following the same sets of procedures. And I was with an aviation unit. There's the ground units that are, the guys pulling the triggers, and there's the supply units that's bringing in food and bullets and gasoline and all these things. And what we hadn't done was coordinate our efforts and define what our standards and procedures were. And one of the most impactful things we did, and I didn't really think about this as technical debt then, but I'm looking back on it. And we put everyone into a room, and we worked out what are the methods, standards, and procedures for connecting all of our units so that we could execute our missions flawlessly. And going through, and it was a multi-week process for us. We had to learn Banyan Vines, learn how to build a crypto cable to connect it to a Cisco router. We had to build a DNS, again, it was late 90s, very fundamental things. And Banyan Vines, probably most people don't know what it is anymore. And how does this relate to the commercial world? And, some problems I've seen with customers in the commercial world, especially in the security space, is firewall rule proliferation. And it's, when I talk about this, is more often than not, when we talk to customers, firewall rules get added, but no firewall rules ever get deprecated, even if a system is taken offline. Nobody wants to go touch the firewall rules because it might break something else, or it might break the system that replaced that system. And I was chatting with an app developer last week, and he used the term architectural sediment when talking about modernizing and securing applications. And this analogy made total sense to me. Those rules get deployed incrementally. There's layers of rules, and trying to dissect those layers. Sometimes you got to put in a quick fix, and you don't go back and analyze what was the root cause of what broke the communication, and why did I have to put this new rule in? Did an app change? What happened? And very rarely are these rules undone. This is classic technical debt because we're not managing that. When you've got 10,000 or 50,000 rules in a firewall, and everybody is deathly afraid of making a change, that is a level of technical debt that creates a ton of risk. Another example, that's pretty common, and it's related to the security example, and sometimes the network team gets involved because the problem starts with, I can't get to X. And then the rat hole that the teams fall into are, it's a reachability problem. I need to put a static route in so that somebody can go the path I need them to go. Or they do some redistribution to quote unquote fix a problem. And once they've done that, it fixes a problem, but it creates a domino chain of a lot of other potential problems, like routing loops, black hole, in the enterprise network. And there's pathing issues, and we've worked with customers, and sometimes it takes years to unwind these things because lots of incremental changes were made over time, and you've got to, you got to be an archaeologist. You got to dig through the layers of sediment to get to the core of the problem. And that really impacts your ability to maintain a high performance redundant path network, which impacts security. Because if you don't know how your packets are flowing, it's really hard to monitor and secure that traffic. Some other very common examples, we deployed messy code because it had to be done. On the infrastructure side of things, network and security, we delay a refresh. That firewall rule set is so scary. I keep firewalls in place well past their end of sale, end of life, end of support, because migrating those rules onto a new platform is scary. And when you're afraid to modify rules, when you're afraid to do software upgrades, you leave yourself open to security vulnerabilities. And there's a whole bunch of other things that we could talk around security and technical debt. Technical debt is a very large topic and very common conversation that we see in software development in an agile lifecycle. When agile teams are doing development, technical debt is a key checkpoint that most agile scrum masters are going to be tracking. Where are we making these choices of speed over accuracy or optimization? And the bottom line here is short-term gain or short-term decisions, they can create long-term pain. And it's all about speed over correctness, I guess is the best way to put it.
Okay, so it sounds like we've dipped our toe into the security piece of this. Why is this such a challenge for teams, and how can attackers take advantage of this?
Well, I've talked about a number of things: unpatched, unpatchable systems, legacy firewalls. I hadn't mentioned data classification, but if you don't have a good data classification system, it's hard to prioritize what do you protect. I think it's pretty well understood. We have a perimeter security architecture, and we're seeing customers move now more towards an east-west security architecture within the enterprise, so that if one host is compromised, it doesn't compromise other hosts. And a lot of times, there could be no policy, or it might be that there's a policy in place, but we didn't have a consistent, uniform mechanism to deploy that policy across all of our policy enforcement points. And it might be at the host level, it might be at a network, or might be a firewall, might be in an intrusion detection. And then we're getting all this data from monitoring systems, and how do you sort through all that noise? And from the attacker's perspective, these are all points that they can exploit to do reconnaissance. We talk about reconnaissance. Hackers are typically spending 80 to 90% of their time performing reconnaissance, determining what kind of devices are in your network. Are the software versions correct? What are the vulnerabilities of the software versions? We're seeing these hacker groups operate more as a collective, or I saw one YouTube video in the last couple of weeks. They were talking about essentially the mob of the mafia of hackers, and they build up a profile, they target it based on the intelligence they've gathered, and they go to steal things, whether it's information, whether it's credit cards, all kinds of things that people can take advantage of. And security technical debt makes it harder to respond to these things.
Mm-hmm. Okay, so with all of your real world experience, I'm sure you have a story.
Yeah, I've got many a story, but the bottom line here is, I said I got to quit saying the bottom line, because there's many bottom lines, but really important. I don't know too many people, if anyone, in IT that thinks that they have all the time, tools, people that they need to accomplish everything that's on their plate. Sometimes choices get made that leave you exposed. And this is generally never malicious, but it's a decision that had to be made in the moment, because you're in the middle of a project, you're at a decision point, it's A or B, and somebody selects B because that's the more expedient option.
Mhm.
And, example here is that we were working with an operations team that was deploying security agents to their workloads. And, and they chose to do it in their production and their user acceptance tests, pre-prod and prod. UAT is pre-prod, prod is prod. But they didn't deploy these same security agents in their dev and QA environments. And as part of our process, we try to bring all the stakeholders together around deploying something new. And this was a zero trust engagement. And we brought the security policy team into the conversation, and they looked at that decision and they said, "Why did you make that decision?" And the ops team was, well, the cost of the agents and ultimately the time to take to deploy um, into dev and QA. We thought UAT and prod were the most important environments to protect. And it was just kind of one of those stupid matter of fact questions. Is you do realize that our dev and QA environments are actually using our production copies of our production databases, right?
Mhm.
And everybody just kind of, oh, okay, yeah, we gotta rethink this, and we went back and redeployed those because you didn't really have a choice. The data was at risk because typically dev and QA environments are pretty wild west, and if you want to prevent any kind of data loss, you have to protect that environment.
Okay. So, what if a team recognizes, hey, we have an, insurmountable amount of, technology debt, technical debt, security debt. What do you think the solution is? How do they go about correcting that?
It's management 101. You have to identify, measure, and manage the debt.
Mhm.
And you have to identify the sources. Is it network? Is it security? Is it app dev? Is it whatever's impacting your technical debt? And there's probably technical debt in all of those domains, and you can't solve it all at once. Um, but once you've done that, or if you work in a particular domain, you have to just look at the technical debt within your domain and be a little collaborative and reach out to your constituents, your customers, or your partners in crime, and how you fully deploy an application. You got to consolidate and prioritize those things. Pick the top 10,
Mhm.
and basically they should be the highest impact or the highest risk. Um, and once you've done that, then you got to do some measurement. You got to develop what are the business impact criteria to assess um, what that identified technical debt could cost the business. And then ultimately you have to build a business case to retire technical debt. It's not easy to go back to the business and say, hey, I need X dollars to fix this problem. And we told you about this when we were launching, but you chose not to execute on it. Nobody likes to hear that, but they always, I want it good, fast, and cheap. And you get to pick two. And generally they pick fast and cheap. And good is the third priority. So, but building that business case is quantifying cost, risk, user experience, potential reputational damage. And, for us here, having the right people, tools, and processes in place. And while they're all critically important, one of the most important parts of solving that problem is having a repeatable set of processes. And that could be architecture. One of the things that we've done at BTA is create our simple service delivery methodology. And it's really about how do we ensure success of any project that we take on. And, we have a clearly defined set of what is the project, what are the deliverables, what are the objectives. And, that's what we need to start. And then when we get into it with a customer, we move into what we call the immerse phase. And this is education. If they're deploying a new technology, we have to educate them about it. Once we've educated them about what the technology can do, then we move into, okay, let's make some architectural choices and some design choices that will meet our business needs. Oh, and by the way, during the immerse phase, we are defining what are the business use cases that we're going to implement to. M is for map, and that's where we're doing our detailed implementation, detailed design, deployment. And then, once the quote unquote, it's done, from a configuration perspective, we move into the proof phase, which is essentially we run a test plan. And that test plan is defined in the immerse phase when we define what the use cases were. We test to the use cases. If there's something over and above the use cases we have to test to, then we need to go back and reevaluate. Is that a use case that needs to be supported, or is that something it's done follow on? That could be technical debt, if you choose not to do it immediately. And then our launch phase is training operations, building run books, defining monitoring parameters, all those things. And then evolve is, hey, let's analyze, let's have a debrief on the project, see, what went well, what didn't go well, what could have went better, and how do we do better next time? And what's the next thing that we need to do to continue to evolve the environment? And that's, and we use this across all our technology engagements, whether it's security or data center or enterprise networking. We find that this keeps our projects on time, on task, and we don't miss. We don't have a lot of mismatched expectations with the stakeholders.
Mm-hmm.
Is that, do we have any other questions?
Yes, we actually have one. It says, thinking about the volume of technical debt is so overwhelming. How do you start?
I'm going to use a bunch of really bad analogies right now, but it's like eating an elephant. You got to do it one bite at a time. But realistically, we just talked about identifying the problem areas, putting it into business context. You have to dedicate time to solving it while maintaining your operations. And that sounds kind of like an oxymoron. It's the classic build the plane while you're flying it answer. But what we found is doing a tabletop exercise where we essentially red team what's going on or where we see the risks. It helps us identify risks. We can take that back to the business. And then we develop, we've got architectural processes and guidance that help clarify the approaches we take. And this is really where we live. Where BTA lives from an architectural perspective, we're architects that work with the business to identify use cases. And once we have a set of business use cases and an architecture, then we can help select a technology that will meet those use case requirements and be something that is sustainable and hopefully has minimal to no technical debt because we've done it all right the first time. We would rather focus on good and fast than fast and cheap. Bottom line, we look forward to engaging with our customers to talk about, how do you mitigate technical debt? How do you assess technical debt? And that's something we love to spend time with our customers on. That's really all I have for today.
Okay, great. Thanks, Ken. I've dropped a link in the comments if anyone wants to reach out today and get engaged with BTA to assess and address their technical debt. Thanks for joining today. And thank you, Ken, for coming on today and discussing this important topic.
Great. Thank you very much, Jen, for pulling this together. Again, thanks for everyone that joined. Please, as Jen said, please feel free to reach out to our team. We'll make sure we get the right person on our team connected with you, and we'll see you on the next one of these.
Okay. Thanks, guys. Bye.
Cheers.